All right, so we have finished the, I guess we're at the break. We finished the remote sensing data sets and nuances, overview of Earth observations for agriculture, and Hannah just covered the use cases. So we're going to go into label data sets, and then at the end we have our demo, and hopefully everybody can kind of follow along from their own computer and be able to complete the task. So we always need labeled data, and so in this part I'm just going to talk about where labels come from for these particular tasks. Some ways it can be collected, and if you're interested, there's some that you can already start using, and I'll mention some of the places where you can get these. So ultimately still trying to go towards things like crop type or crop conditions or yield. I'll be talking about sort of the inputs for that. So ground truth data sets, it's like ground truth. If I'm standing here, my label would be carpet. So that's sort of something I can visibly, say what it is. Can be collected multiple ways, can look different ways. So for Earth observations in the past, you'd go with a GPS, record the point, and then with the old GPS, you would have to go upload the data in a GIS software and add the label into tables. And then if you want to do boundaries, you walk around the field and kind of record that. So these are examples of the formats that you get for labeled data. And then in addition to, the point, the location, like there's a crop field here. You'd have other things like what the crop type is. You can have additional things like yield if you go at the end of the season. You can have additional things with newer applications that are available. You can say like what kind of species of rice it is. You can add when it was planted, and all of that information is useful for, for different use cases. And so for cropland and crop type, some examples of how it's typically done, or things like pest and disease, you'd physically go to the field, record the location, you can take a picture, and then with modern applications that we use, you have a simple form that you fill out, uses GPS on your phone, records the location, you can enter all the added information, and then later on, those data are aggregated. What is the reason for doing ground truth for things like crop type, for example, is sometimes there are multiple crops in the field. You can't see that from satellite data. And sometimes these crops might be like in different stages. So you might be looking at sugarcane, for example, or you might think you're looking at sugarcane if you're looking at a satellite data set. Yet you're looking at grass, or you're looking at sorghum or cassava, sorghum or maize that might sort of have a similar texture-ish, but it's sometimes impossible to do that. So you almost always have to go into a field. And then the data are aggregated. This is an example of an aggregating service or portal where after you collect all the labels, you can look at them on a map, you can zoom in. And so, for example, this graphic right here is using that application. You can inspect whether the point actually falls in a field or if it doesn't. Other fancy ways for collecting data, drones, which sometimes you can kind of distinguish what the crop is. So this I know because I was there. So it's like I was literally on the ground still. We have banana here and maybe some maize here. But you can, when you zoom into this picture, it's I think 4 centimeter resolution, you can see the fields that there are. You can use this would be a good data source for doing like field boundaries, for example. For doing things like cropland, we can do on-screen labeling. So we, in our group, we use Collect Earth Online as one of the tools where you can look at a multiple set of satellite images, some that are freely available, others, through some other services, as Hannah was mentioning before. And then with that, we can label, for example, whether we're looking at cropland or not. Cropland has texture that you can kind of see when you look at a reasonable resolution, reasonable spatial resolution image. Other ways, you can use GIS software. You can see pretty much a lot of the open data sets in GIS, and then you can generate your own labels. You can draw boundaries this way as well. And then other things where you can find higher resolution data like Google Earth, you can generate a bunch of points and label them in Google Earth. Some of the, we call this emerging. I'm pretty sure there are lots of groups that are trying similar things. But in our case, we're trying to do rapid data collection using cameras. So Hannah mentioned this, the helmets approach, which is collecting data on motorbikes as you're driving. We take pictures using GoPros. And then from those images, we're trying to use computer vision to label all the images, like label the crops that are in those images. And then from that, using, am I remembering from today? Yesterday? From yesterday, yes. So I think it was recorded. So Hannah gave our street to sat presentation in the workshop yesterday, in the Ag Vision workshop. And if you're interested in learning a little bit more about this, you can check it out. So other sources of data, we're not only interested in crops, especially if you want to create a cropland map or crop type map. You need these additional data sets that give you examples of things that might look like crops but are not crops. If you had a really good data set on, like, let's say grassland, you can exclude all the grasslands, or you can use it as a label of an example of non-crop. We can remove buildings, but you can also, if you're interested in labeling, for example, if you're interested in doing, creating a building data set, you can use this for training and then try to find buildings everywhere else in your images. For things like yield, it's very complicated. You can have a very fancy harvester that records as it's harvesting grain, for example. This is not so common. It's common in highly commercial, really large fields, and is largely non-existent, for example, in Sub-Saharan Africa, where you have very small fields and a lot more complex agriculture. So, for example, that harvester wouldn't work if that field was, if the field was the size of the harvester of that field was this field here. So that field will hold everything out and, kill your beans while it's harvesting sugarcane. So it's much more complex. And so some of the other things, we can access yield data through government organizations like the USDA publishes some of their yield data. And to show you how complex and expensive and crazy it is an example from Kenya. All these images here, they draw these tiny plots. I think they're 10 by 10 meter. And then they go in, harvest all the maize, and then thresh it, weigh it. And then sometimes, if you're involved with a research university, you could weigh the grain and then later on use it for very fancy things. So we're trying to do some of this, but through partnership with other individuals. And I think that's potentially the most sustainable way of doing it. In terms of data sources, there are quite a few things where you can find data. There's the Radiant Earth ML Hub, where there are machine learning ready data sets that you can go. There are quite a few from around the world. They have competitions sometimes. They have data sets on field boundaries, points. I think they share the original data as well as the machine learning ready, pre-prepared, really clean data sets. And if you have your data set that you want to publish, they also do that for you. There's Zenodo, where you can go in and find shape files. For example, our Kenya data set with the points as well as the map is available through Zenodo. So you can kind of check that out. We've been working on this crop harvest data set, which is right now it has about 90,000 labels of crop, non-crop, and fewer labels of like crop type. And we're adding to it as we get access. It's open access, so you can sort of already use it and contribute to it. And I think Ivan will mention it during the demo. There are other places through competitions. So sometimes someone is trying to solve a problem and try to solve that problem, recognizing that there are other people who might have better eyes or better methods, or better tools. They share like these data sets that will not be available at all, even if you try it really hard. So you can find like very good field boundaries that you can use that you wouldn't be able to find otherwise through these types of competitions. And the other way to collect data is you can go do it yourself. There are simple applications that you can customize and go out and collect data. You can do very fancy things, especially if you have a field that you have access to. You can bring tape measure, you can walk the boundary, you can label every single thing in that particular plot, and then try to see if you can scale it with satellite data. And then I did mention this a little bit. After you collect your data, you have to visualize it. It might look very different than you thought. You might think you're walking a boundary and it ends up having like 3 points rather than 4 or 6 or 7, depending on how irregular the field is. And you can do this with GIS platforms. We use QGIS, which is an open source one. There are others that you can use. You can look at them in Google Earth Pro, where you can also have access to high resolution satellite imagery, but also street view. So you can actually see what might have been there at some point. You can use Google Earth Engine, where Ivan will talk about this. There are a whole bunch of satellite data sets that you can use, and you can sort of leverage their compute for pre-processing and getting your mosaics ready. And then there are Python coding libraries as well. And then I guess I already talked about this. And then ultimately you want to combine your images with, your labels with satellite data, and then go through the whole training, inference, and then you have your map, and then you can evaluate it. And we're going to go through that with Ivan. And so in the end, when you combine them, it could be different things depending on what your satellite data set is. It could be different bands. So anything from, I think it's about 13 if you have Sentinel-2 and you have NDVI or GVCI as bands, and then you can classify your image. And so next will be our working session. It's a demo with Ivan.